Ba-da-da-dum, ba-dum-bum-bum.
Here we go.
Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 131. Have a heart, Transputer pie, just the wing, and a flipped cable fries radio. Let's see. New this week. Well, not new this week, but we published some news this week. That there was a very large lithium battery fire down under.
If you have ever been one of those people who thinks that lithium-ion, lithium polymer batteries are danger waiting, imagine when you have grid-scale storage and it catches on fire.
Yeah, so there's an installation that Tesla is working on with these, they call them mega packs, but I think they're actually shipping container size, like the 20-foot shipping container size, and then they fill them up with lithium-ion cells, and then they connect them to the grid. And when there are temporary outages, these can come online, in the blink of an eye and bridge the gap until they can get backup generation running. They're installing 210 of these pods, and one of them caught fire at the end of July. And interestingly, I saw some video clips of this, and you see water coming out of hoses, and I'm thinking to myself, what is going on? But they're not watering the fire, Elliot.
Instead, they are.
They're watering the neighbors. They're watering these shipping containers on every side of the one that's on fire, because you need to keep them cool so that they don't also catch fire. But I think unless you have a helicopter full of sand, you just let the one that's burning burn itself out, which is why it took a few days for them to put it out.
I'm a little bit surprised that they don't have water piped in on site. Like, I guess they're still building it, so maybe they haven't done the fire safety stuff yet, or maybe
like
have
sprinklers
safety
that would automatically
start
up, mm-hmm.
Except on a scale that would shut down 2,000, 5,000 lithium-ion batteries when they go on fire.
Well, I think that the water just makes it worse, right? Doesn't the water react with the electrolyte?
Water's the only way you can really cool these things down, though. And the game is to get the battery cold enough that it stops being on fire. And so the good way to do that is with a ton of water. I was actually reading up on it, and here in Germany, they have started dispatching 4 times as many tanker fire trucks to electric car fires as they would to a gas car fire. Because what they say is it just takes about 4 times the volume of water to get the fire under control. So you're partly right. It's not put water on it and it'll stop reacting. It's you have to get enough mass of water onto it that it can cool the thing down so that it stops.
I mean, this is bound to happen at some point. You have, grid failures all the time. It's not like, grid equipment catching fire is something new. It's just that this is a new piece of grid equipment that isn't in very many places in the world. In fact, this is like a test installation of it. And so it's notable to look at it and see that this happened and see how they got it under control. They ended up having one container that was next to the one on fire also catch. But those
yuck.
2 are all that they lost. So I guess 1% of the installation was lost in this. It'll be interesting to see what comes out of investigations. In general, I'm all about having grid storage because I think it makes sense for, excess energy and for, in this case, rapidly filling the gaps when you have a problem with generation. What's that sound, Elliot?
This is a journey into sound.
What's that sound?
What's that sound?
What day of the week is it, Mike?
It's Friday.
It is. What number of the month is it?
Hold on a sec. Hang on. I'm almost there. It is 0x0D today.
It's Friday the 0x0D?
Yeah, but some people call it Friday the 13th.
Yeah, that's a lot of people, I think. and that would be too obvious. But picking up on the scary theme, I've got some spooky sounds for you this week. So have a listen and see if you can tell me where this comes from.
guess it's Resident Evil.
Nice guess. I have to say, this is one where you just either know it or you don't.
Nope, I don't know
But
it.
you're on the right track. You're not far
Yeah.
off. I actually almost did Resident Evil.
So it's not Resident Evil, but if you know what it is, we want to hear from you. You will find in our show notes at hackaday.com/podcast a link to a Google form. If you're right, we will randomly draw one person from that pool of right people and send you a Hackaday Podcast t-shirt.
Hooray!
Hooray.
And so good luck, everybody, despite it being Friday the 13th.
We're leading off our favorite hacks this week with one involving Tamagotchi. If you are not familiar with the 90s craze, Tamagotchi are keychain-like electronic devices that you carry around with you. They have a tiny screen on them, LCD screen, 32 by 16 dots on there with 3 buttons, and an egg would appear on the screen. The egg would hatch, and an animal known as a Tamagotchi would come out, and you could feed your Tamagotchi and water your Tamagotchi and play with your Tamagotchi and give them attention and give them medicine and do all kinds of things and try to get them to keep living. If you did that, I don't actually know what happened. Do you know what happened?
I never got that far. My Tamagotchi's always like starved or got grumpy with me, or they end up like crying and that's the end of the game or something. I've forgotten how it goes.
But we're not talking about the original hardware on this. We're actually talking about Tamagotchi running on an STM32, which I think is pretty cool. They have one of those discovery boards in the picture here, and JC has added, just your run-of-the-mill OLED screen to it and a couple of buttons coming off on jumper wires, and you could watch Tamagotchi running.
And I think what's really cool about this is that this is a port to minimal hardware, and that means that you can start porting it to whatever other minimal hardware you feel like. Where else are we going to see Tamagotchis popping up?
I mean, that's a good question, but JC's got the tools no matter where you want to go, because there's 2 repos to this. One of them is a hardware agnostic library, and then the other is like the debugging tools, basically. And so you can go in and see what's happening. You can extract resources from the ROM, which has been dumped from the original, like version 1 Tamagotchi hardware. I really liked reading through the clocking issues on this. JC says that if you look at the original, it runs on a clock crystal, so 32.768 kilohertz. Each clock cycle, or each instruction takes multiple clock cycles. So you're looking at 153 to 366 microseconds per instruction, which if you're running an emulator on top of a microcontroller, like that's actually pretty tight timing. Unless you're going to grab something like that Freescale chip that runs on the Teensy 4.1 that runs at
which is super fast
on 600 megahertz or something like that. So there are some ungodly fast things out there, but I think the interesting thing about this is it probably will run on a blue pill if you're really creative with how you get it on there, which is pretty neat. Of course, we can't talk about Tamagotchi without talking about Sprite TM, who hands down,
dude,
in 2015 at the Super Conference, I think my favorite talk of all time.
That was pretty crazy
to have watched. He built the infinite matrix of Tamagotchis, where he figured out how to get the Tamagotchi ROM running on a server, and then it was scalable to however many you wanted. And then he took an ESP8266 and put it inside of original Tamagotchi keychain, so that you could basically SSH into the running emulation on the server and have the output of it shown as if it was in the Tamagotchi that you were holding. So if you have no idea what I'm talking about, stop what you're doing, put the podcast on hold, and go watch this video.
And now that you're back from watching that video, let's talk about the crazy future. My first hack this week is From Tube and Wing to Just Wing, the Future of Airliners. And this is a write-up of a video by Real Engineering where they look at what's wrong with what we all think of as an airplane, which is basically, think of an airplane. It's a big tube with a couple wings on the outside. And what's wrong with this is that the tube and the tail, I guess, that goes along with it don't contribute anything to lift, but they do contribute to drag. And so they're kind of the inefficient parts of the airplane. And the idea is, what if you made an airplane that instead was all wing and yet could still carry passengers. So just kind of minimizing the size of the wasted airframe to minimize drag, to maximize fuel efficiency, to make the world a better place. This is a real problem, but it's an old real problem. It's been kind of, a dream since the 50s, since people have kind of really understood aerodynamics and realized that the tube part of a plane and the tail is basically just dead weight, but it's the dead weight that carries the people in the most obvious way. And as they point out in this video, I hadn't thought about it. Having a tube means you can make it longer and shorter at will. And so you get 737s have all of these different varieties of them that are basically just longer tubes or shorter tubes. There's like a stretch and an ultra stretch and whatever else. Besides making it cheaper to manufacture, this also means that you don't have to retrain the pilots on the airplane. So if you can fly a long 737, you could fly a short 737. So there's a bunch of reasons you want to make these kind of tubey style airplanes. But the flying wing planes, they look like manta rays or something. They're just so freaking cool.
Looking at this, there's a lot of merit in the comments when they say that people are going to want windows.
And they've thought of that. They are going to put an LCD screen showing you a picture of the window. Yeah, I'm not convinced either.
Are the passengers still just down the middle of this thing, or do they get to spread out so you get 10 rows?
Yeah, I think that's it. I mean, I think the plane, instead of being like a long tube, is basically a big square. Could be like an open plan office or something in the middle.
Hot tub.
It really makes me wonder how attached we are to things like windows and the things you get out of that tube design. I mean, honestly, you've flown on these big international flights where it's like there's a row of 4 or 5 in the middle. You don't have a window when you're sitting in the middle of that row.
Right, but I was booked super early, so I get a window because I like the window. And then
you're holding back progress.
Right. Well, the thing I don't like is they come and they tell you you need to close the windows now because they're trying to change your time zone.
That's right.
And I'm like, I don't want to close the window. This is why I'm sitting here. And then you're sitting in it. I don't know. I think you could maybe get over that stuff, like LCD windows. Yeah, fine.
Yeah.
I think if it means that international flights are faster, more environmentally friendly, I think people will just be able to do it.
And that's what I think about windows too. I mean, I think that's a concern you have now because you grew up with planes with windows. But, people in the future who grow up with flying wing airplanes will just be like, quaint, they used to have windows in their dirigibles. The only thing I don't know is whether when the plane banks, when it has to turn, the people in the middle aren't going to notice it. For them, it's going to be like a normal plane. But are the people who are out toward the wings who have to move a lot further when the plane leans over, are they going to be is it like a roller coaster for them?
Yeah, your hands are in the air if you're in.
That's right.
If you're in seat 1 or seat 70.
That's right.
I'm here to share the tale of woe.
Uh-oh.
On Doug's new Yaesu FT891 radio that he installed in his vehicle and went to power it up and let the magic smoke out.
That is very sad.
It is very sad, but we all get to benefit from Doug's teardown of this, which is an awesome tour of what's going on. First of all, the culprit is an RJ12 cable, like the old telephone type of cable that connected and powered the unit. This cable was put together with one of the connectors flipped, like it's a crossover cable.
Right. They used to have those.
And maybe on purpose, I don't know. Like who knows if this was a mistake or not. But the big problem Doug comes to find out is that the two center pins that are next to each other are plus 13 volts and ground. And so those got flipped. And so plus 13 volts was going to this. Now, don't worry. There was a fuse inside of this that did nothing.
Oh, that's nice.
It did something, but not until something else already burnt out. So as he was looking through this, and it's a fun fun story of how he went to look at the failure testing on this, but he traces it down to a very obvious black mark on the circuit board that used to be a resistor. And in drawing out the circuit from the repair manual, finds out that about 1.3 amps was going through the system, and the fuse is 1.25 amps, so the fuse didn't blow. And this 1.3 amps all got dumped into a 1/8 watt resistor. And if you do the calculation, that's 16.9 watts
Hot.
through an 1/8 watt surface mount resistor, which ended up burning the pads right off of the circuit board. Obviously, just melted the resistor. And then at that point, the fuse blew. Because then the fuse is like, oh, this doesn't feel very good now that we got this massive short in here.
If that's your damage, if your damage is not just a fuse, but like also a resistor, you've actually had a good day.
I think so too.
You're not happy about the situation, but
I would think about that on something that I put together. If I bought something and then
That's
it
right.
required not just surface mount rework, because his rework for this, there's no pads left to solder something to. And so he traces where those pads were going and ends up soldering like an axial through-hole resistor between the 2 points because it'll reach, which gets it up and running just fine, no problem. The horrible part is in the schematic for the service manual for this, I think there are power regulators that ended up causing the problems have reverse polarity protection on them, and they've just decided not to populate those diodes. So 3 diodes, the cost of placing 3 diodes on this board would have saved it for Doug.
I never put reverse polarity diodes on my things. I always plug them in the right way, right?
Right, but when you buy something, don't you expect it to have reverse polarity protection? I do.
My next hack comes from Les Wright. This is using a laser to blast away a Bayer array. Say that 10 times fast. Les has been working for a while on a Raspberry Pi spectroscope project. And a spectroscope, let's see, you shine light on the test object and it tells you how much of that wavelength of light makes it through. What you need to make a spectroscope then is essentially a light sensor with a very well calibrated and well-known response, because you're trying to figure out how much of each different band of light makes it through. And the great way to do this is to take a camera and convert it from being an RGB camera into a wideband black and white camera. And that's what he's doing here. I never really thought about it hard enough. I always thought about the little elements in those CCD array cameras as being somehow color sensitive, but they're not. There's actually a filter in front of each pixel that is, lets only red, green, or blue light through. And what he's doing here is getting rid of this color filter so that every sensor on the little Raspberry Pi camera is equally sensitive, and he gets nice uniform intensity data across, and it extends out into the IR and the UV on either ends. He first tries to do it just by scraping the Bayer filter off, and that works except at the edges where he ends up fouling up probably connectors that connect the CCD to the wires underneath. So that's not going to work. He has to figure out a non-contact way of doing it. And those include a bunch of heinous chemicals, but instead he decides to blast it off with a laser. And if you know the name Les Wright from Hackaday before, it's because he has played around with a bunch of awesome homemade lasers. He's made the coolest TEA lasers that I've ever seen. And his spectrometer project has also graced our pages before. I'll throw some links in. The point here, he builds a nice little machine that just scans the camera sensor back and forth under the laser, and the laser goes zap, 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 and just melts the plastic away, cleans it up, and he gets a marvelous result out.
I just can't believe this works for so many reasons, Elliot. I mean, the first one being that you assume like any mote of dust
right
is going to just screw up your camera sensor, right? So like I wouldn't think that burning plastic with a laser would be okay. And then I think the other thing is I've heard that if you point lasers at camera sensors, you can damage the sensor.
Yeah.
So you would think blasting directly at the CCD would also be a problem. Maybe the wavelength is okay for the sensor, or I don't know. It's it must be a tricky dance to get it done just right.
And so as he's like zapping this away, you can see crazy dust and debris from the blown up Bayer array landing all over other parts of the sensor. So you're not wrong. Like, this is a messy piece of work. He cleans it off. In the end, he points the sensor up at a ceiling or something flat illumination, and you can kind of see 2 little spots on it. And he thinks that maybe he just missed a couple spots and he's going to go hit it again with the laser and see what happens. Anyway, it's a really cool trick, and it gives you a camera that, although it's just black and white, has incredible spectral sensitivity, but because it's only black and white, it doesn't have this Bayer array of green, blue, green, red on it. So you actually get 4 times the spatial resolution out of the same sensor as well. And that's not bad for one of these little $5 Raspberry Pi cameras.
Speaking of Raspberry Pi, this next one is an incredible example of how you can use the Raspberry Pi Pico. That's the microcontroller board that has their original silicon design of the RP2040 chip on it. And in this case, Amin wanted to play around with the Transputer. In fact, has always wanted to play around with Transputer chips since they first came out in the 1980s. The interesting thing is they were very expensive then, and they're not any less expensive now because they were designed for parallel processing. So you needed multiple of these chips. And so if they were expensive back then, not very many people bought multiple of the chips and hooked them together. And that means that there's like no resale market for them. 40 years later, still wanting to play with this, along comes these $1 chips, or I guess they're $4 dev boards if you buy the dev board, that has an interesting hardware peripheral on it that are those PIOs, programmable input-output units. And the reason that this makes sense is the communication standard for the Transputer had 4 different, basically serial ports, 4 different I/O lines on them. They called them links. And in order to mimic that, you want like a low latency. I think they operated at something like 10 megahertz. They were pretty fast communication lines. And so in order to get there, you want to have hardware running that. And Amin looks at the RP2040 and says, oh, it has 2 blocks of these PIOs. Each has 4 state machines in it. That's 8 state machines. I have a total of 8 of these lines because it's 4 lines and they're bidirectional, so 2 per line. Perfect. You can do that in hardware. You just have to figure out then how to internally connect it to an emulation of the Transputer chip itself, and mission succeeded. That doesn't quite get you across the finish line, though, because you can have multiple Transputer chips and you can connect them to each other, but you don't have a way to interface them. So the other half of this project is actually building an interface with one of the original chips that you would use to break out lines and connect it to the links of the Transputer array.
Really dumb question. What's a Transputer?
It's the architecture of chip. It's like saying an ATmega, right?
Oh, okay. It's like a brand name.
Yeah, I think it is a brand name. Well,
sounds futuristic, frankly.
It was Inmos is the one that developed these.
Okay.
I think it's like a Pentium, right? What is a Pentium?
That's a brand.
But we've all heard of that.
Right.
So it's a Transputer.
Oh, totally a Transputer.
Yeah, so you can't get Transputers for a reasonable price, and you can't really get hardware that was in unless you're really willing to shell out. But you can get these IMS C011 chips that are meant to interface with them. And so what Amin did is took one of those, talks to that chip with an Arduino Mega, and then that lets you, use a serial port or wherever you want on the Arduino Mega to basically make a terminal. So you can have a screen and a keyboard. To me, another really interesting part of this is like, how do you do the software on these? And that's something that you can do it by hand, which is what the first thing that was done here, just kind of proof of concept stuff. But Amin's looking for a better way to compile this. Right now, the compiler that's available, you have to run it in like a virtual machine using DOSBox. And Amin's thinking there must be a way to maybe use the second core of the RP2040, which is doing nothing so far, and make that like a compiler. So you could send code to it, it would compile it and start running it or something along those lines. So I'm excited to see where this project goes.
Transputer. It's
monorail.
Exactly. Last hack of the day, ESP8266 network meters show off unique software. This is a great work by David Chatting and a couple friends. The first thing that grabs you if you look at this on Hackaday is that there are 3 kind of cryptic little devices that show you some kind of information, and you kind of have to figure out what. It's actually really cool. One of them is a Wi-Fi proximity sensor. The other one shows how much traffic is going across the Wi-Fi by spinning a black and white disc. And that's just lovely to watch it spin faster as you use more bandwidth. And then the last one is kind of a spiraling graph of activity over time. Think of like an old seismograph that would record on paper. It's kind of like the OLED or LCD version of that. Anyway, the devices are awesome, but that's not what is going to be interesting to you if you're into like do-it-yourself home automation. Because what makes these things work are an ESP8266, which of course we've all got, but then two really cool software libraries. And the first of them is done by David himself, and it's called Approximate. And what it does is it uses the RSSI, the received signal strength, in the ESP to figure out how close it is to other Internet of Things devices that maybe you have running around your house. You can bring your ESP with you, and when you get close enough to, say, a light bulb, it just turns itself on. And this is really clever because you can make a very small, low-power device out of this ESP that's always kind of beaconing, and then have these things that are plugged in, listening for it, figuring out if you or your device is close by, and then fire up. The other thing you could do, of course, we all have cell phones that have Wi-Fi in them. You can do the same thing with the cell phone. This looks like a really fun library to play around with in your own home. Yeah, you could do the Where's My Keys application with it. You can do turn this on when I enter the room. You could do unlock this door automatically. It's just a really handy and interesting library to use. The second library was written by David and two friends, Mike Vanis and Andy Sheen. This is called Yo-Yo Machine's Wi-Fi Manager Library. And this is a super captive portal way to set up an ESP8266 or ESP32 based Wi-Fi network. And so it opens up a portal. You can customize things. It looks like this will help you make your devices easier to configure, easier to get online, and easier for people who aren't ultra mega nerds to configure.
I do like the devices though. Like I'm smitten with the aesthetic of this large yellow rectangle as the faceplate, and then off to one side it has the circular opening for the actual data transmit thing.
Right.
Because the large yellow flag, it reminds me of, I don't know, like railroad caution symbols or something. Like it just screams to you, there's information you should look at right here.
It's civil defense yellow. It's the color of those old like Geiger counters, right?
Yeah.
But what's cool actually about this design is it's actually a removable faceplate. It's a little piece of plastic that slips over two screws. And so if you feel like having your Wi-Fi notifier thing be yellow today and red tomorrow, you can do that too.
First up on my list of quick hacks is improving OLED VU meters with a little physics. This is a pretty simple example of how to make awesome reactive displays. SJM 4306 uses Bresenham's line algorithm to draw the needle on top of the graduated display that would normally be on an analog meter, all done with a light up OLED. Next up, wristwatch PCB swaps must be in the air. We just looked at a wristwatch PCB swap by Dave Darko last week. Here's a new one by Joey Castillo that has the Casio F91W wristwatch, which you can go and buy in your local Wally World if you want. Totally swapped out with a different chip. And do you remember, Elliot, last week I was wondering why that SAM L22 chip was chosen?
Yeah.
Now we have the answer. It has a built-in segment LCD driver on it. So it's perfect. So now I need to get a segment LCD because I want to play with these. Last up I have wooden keyboard with Scrabble tiles goes the extra mile. Steve M. Potter decided to build his own keycaps out of Scrabble tiles nonetheless. And so these are just 3/4-inch wooden dowels topped with Scrabble tiles for each letter and then sanded round before being inserted into a very epic looking keyboard.
My first quick hack is workshop organization with panels from another maker / develop with Dan. And this solves a problem that I've always got, which is what should I do with the cool and crazy little things that I've built? Here, he's built a paneled wall that looks like it surrounds his desk or something, but the panels are each removable, and so you can pull one off, embed your project in it, and put it back up on the wall, supply it with power, and you can surround yourself with an ever-growing army of awesome projects that you've done until the whole thing's filled up. I love that as a aesthetic, but also as a motivational tactic. Next up, Giant CNC Machine measures a full cubic meter by Brian Brocken. Normally, when you think of a 3D printer, it's kind of a small thing. Or if you think of a CNC machine, it's a really beefy thing. In this case, he's trying to build a generic, lightweight CNC machine. And when you look at a meter by a meter by a meter and try to fit one of those in your living room, it's actually surprisingly big. I think this is a neat design because he's not aiming to have this thing be heavy duty or hold heavy loads, but instead to do something like cut foam with a hot wire, which has essentially no load on it, or maybe be a slow 3D printer for things that are really gigantic. I think it's a neat design, and I want to see this one get finished up. Last up, David Lovett's homebrew ROM reader saves data from a vintage mini computer. He's got a mini computer I've never heard of, a Centurion, and the ROMs from it. Just wants to save the ROMs for posterity because who knows when you're going to run into those again. The dumping apparatus here is extraordinarily simple. It's just a counter that goes through the different addresses and then an Arduino that reads the data out of these ROMs and transfers them to his computer for archiving. If you've never played around with old ROMs before, it's really fun, it's really easy, and this video will take you through how he did it.
We have arrived at our Can't Miss Articles of the Week. This long-form content has been written by excellent Hackaday authors, and I chose one by Lewin Day called A New Flying Car Illustrates the Same Old Problems. This is not ranty from Lewin, but it's going to be ranty from me. What you have here is Klein Vision Air Car is where the jumping off point for this is, and it literally looks like a futuristic, like bubble domed car, but it's 500 feet in the air with a couple of stubby wings coming out the sides and a dual tail going off the back. And that's cool. And if you just built this and flew it around, that would be awesome. But then if you said like this is the future of travel, then I gotta get off the train at that point and say, first of all, aren't planes already flying cars, Elliot?
They can't drive around the city.
Yeah, so you got to be able to fold up.
You have to be able to fold the wings
fit where a car can fit.
Yeah, you have to be able to park it in a reasonable parking spot.
Right, and like this one's got the propeller on the back.
Yeah,
it's pushing rather than pulling. So you're not driving with the propeller and that sort of thing. So there are some differences there. But can you imagine if, let's say, even 25% of the people on your street owned their own flying car?
I think you and Lewin both totally missed the mark on this one. And I think it's not meant to be a flying car vehicle for anybody. It's meant to be this guy's dream. And this guy is a crazy adventure pilot plus radical engineer. Like, this is one man fulfilling his crazy dream to get himself a $1 million air car, and good on him for doing it. I watched a German documentary about the Klein air car, and it's funny because the reporter goes there saying, I'm super skeptical. I don't even know if this thing's going to work, et cetera, and he leaves there just like enchanted by how crazy this thing is and totally pissed off that he wasn't allowed to fly in it. Because this thing is still so experimental that only Stefan Klein is willing to drive it himself. And in fact, he almost died in a previous prototype crash falling out of the sky, except it has this emergency parachute system on it, as does this one, because it saved his life before. I think this is never going to be, and Lewin points this out, I think this is never going to be the solution for travel anywhere. It's less efficient than an airplane. It's slower than a fast airplane. The only thing it is hella cool. if you're a pilot to be able to drive your car. And watching the wings fold up, dude, it is so awesome.
This actually reminded me of those personal watercrafts that are like sealed submarines.
Exactly.
Painted to look like orcas. Do you know the thing I'm talking about?
Sure.
And they're like, I don't know, they're $1 million.
Yeah.
It might as well be $1 million because that's about how attainable they are for someone like me. And I just look at that and I'm like, so you can't say, everyone who lives on a shoreline and has a boat is going to have one of these orca subs.
Exactly.
It's just not reasonable. And so the other thing though that popped out in my mind, are we going through some kind of like space race tech nostalgia boom?
Okay.
Like as we get the space race again, because flying cars were a big thing in like the 60s, right? When the space race was happening. So do you think we're getting some fall off from that again? Like these same ideas that are just never going to come to widespread fruition are kind of romanticized in people's minds?
Yeah, except the space race worked and the flying cars never really did, right? Yeah.
Right, but we're to the second space race now. It's like, well, maybe this is our time. Maybe it's our chance.
Air cars again.
And I just think of, how when my neighbor across the street fires up his motorcycle at 9:30 at night, I grind my teeth and I'm like, what if that was an air car? Like that's got to be significantly noisy trying to land on your street. Although I think that's also the point of this is that it's an airplane that can drive on streets. So it's not like you land it in your street, which is, I guess, further proving my point. Like it's not really an air car. It's a car and it's an airplane, but it's never both.
I think it's much more of an airplane that turns into a car. Like you can land this thing in a field and then like fold it up and drive it over to your neighborhood. I think it's no problem. I think this guy could be living next to you and you wouldn't even know it, except for the crazy
odd-looking
crazy air car driving down the street. My can't miss article this week is permanent artificial hearts. Long sought replacements may not be far away. And this is Dan Maloney writing up progress in building artificial hearts. And I guess the news that sparked this article was a press release from a company that has made an artificial heart that is small enough and powerful enough that it can be basically self-contained inside a person with a power cord running out to a battery outside. And if you think that this is not some kind of a revolution, you haven't seen earlier artificial heart prototypes because they are pretty terrifying. And what I learned from this was there's an artificial heart from the 1950s that was a Dodrill GMR because it was made by General Motors Research. And this thing looks like, I don't know what. It looks like it's got awesome analog valves on it. It looks like it's a car part or something, and
it looks like you would find it in an abandoned tech lab from, I don't know, Chernobyl, the city of Chernobyl.
Yeah,
right? Like locked in time type of
totally
equipment.
Yeah, and it's absolutely gigantic, but it solves the problem, which is pumping blood in place of your heart. When pumping blood, you can't just use any old pump because blood is actually, it's kind of a living tissue and you have to be a bit gentle with it. And so you can't just squish it or run it through a fan motor or something. That would homogenize all your platelets and that would be a very short story. Instead, all of the artificial hearts have to do this kind of pumping. So for instance, the Jarvik 7 artificial heart that you might be familiar with is made up of like rubber valves that imitate a human heart, but it's compressed from outside by, I think that one's pneumatic. There was another one that was done using hydraulics, and I get them confused. But these are all essentially powered from outside. Which brings us to this new model from Bivacor, and it's actually an impeller-based artificial heart, but they've figured out a clever way to magnetically suspend it so that your blood platelets don't get squeezed in the bearings and smooshed by the propeller fans. And that looks like the secret. There's also, advances in motor technology and sensor technology that make this possible. It's got a lot of smarts in it to avoid damaging your blood. The creepiest thing about it is that it just seems to run.
So are you talking about the digital pulse news with this one?
I'm talking about first the lack of a pulse, and then but
Right.
go with it.
Yeah, so this one is capable of just running the impeller, and so it just constantly pumps. And the way that that's different is your heart has chambers in it. And so you have a pulse as fluid is pumped from one chamber to the other chamber and then out. You would lose that. And one of the questions that Dan asks in this is there a biological imperative for a pulse? I don't know the answer to that, but I know that from debugging electronics, checking a pulse is like the best debugging thing. Like anybody can do it at any time, and it's pretty obvious that there can be a number of things wrong just from using your fingers to check a pulse. So it's interesting not to if you were not to have that. The other thing, going back to like the Jarvis that Dan mentions in this article that just, I wouldn't say it blew my mind, but it kind of put me over the top on how excited I was about this article, mentions that if you want to have an artificial heart pumping and you're doing something like pumping it from the outside, you are having flexible materials that are constantly moving every second of every day for the rest of your life with this thing implanted in your chest. And you really don't want to replace that thing because it's, you could say, invasive to be swapping hearts out. And so they've just had a horrible time with materials science finding something that will hold together to that much flexing. And so that's another place that this impeller design is really brilliant, is that, you know, having something magnetically suspended that's spun from, you know, inside the heart, but externally from the veins and arteries themselves is really cool.
The previous artificial hearts were really meant to be stopgap solutions until you can get a heart transplant in. And so, like, they don't last for very long, but the hope was that they wouldn't need to. And so the hope is that you could find a new replacement human heart within the 10-month period before the valves start to go or whatever. And what's really weird and different about this one is that I don't know how long it would last, but it's presumably going to be a lot longer than 10 months or whatever, because the way the motor is constructed, it's got magnetic bearings. So there's no like wear parts inside the motor. It opens up the creepy possibility that you could have an artificial heart like forever.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, please tell us about it. tips@hackaday.com. And until next time,
keep on hacking.
Welcome to the Habit. Blah. And a flipped cable. That's all the time we ever visited this. I couldn't do it. I wasn't ready. Bresenhams. SJM 4306. Use Bresen.
I wish I could do an Australian accent.
I also wish you could do an Australian accent.
Good gravy.